Hi everyone, my name is Emily and today we're going to work on a stoichiometry problem. The first part of this question is asking us to balance the chemical reaction. Now the easiest way to balance a reaction is to balance the elements that appear once on either side of the equation. For example, if you look at carbon, that appears once in ethanol and once in carbon dioxide. We see that we have two carbon atoms on this side, so we have to have two of them here. So we need 2 in front of carbon dioxide. The next one to balance would be hydrogen. We have 6 of them on this side, but only 2 on this side. So 3 times 2, that will give us 6 hydrogens. And the last one to balance would be the oxygens. We see that we have 1 plus 2, 3 on this side, 4 plus 3, 7 on this side. So how are we going to get 7 hydrogens on that side? Well, we have oxygens. We have 1 oxygen here and 2 of them here. So if we just simply multiply O2 by 3, then we'll have 7 oxygens on both sides. So that's the balanced chemical reaction. Second part asks us what kind of reaction this is. Well, based on the reactant and the products, we can determine that this is a combustion reaction because we are burning, in a sense, ethanol with oxygen gas and getting products of carbon dioxide and water only. So we know that this is a combustion reaction. The third part of this question is asking us to find the total mass of the reactants if 5 moles of ethanol react with 15 moles of oxygen gas. So basically, we are going to be converting 5 moles of ethanol and 15 moles of oxygen to grams of ethanol and grams of O2. And the way we can do that is by using the molar mass of ethanol and oxygen. Now I'm sure you can do that on your own. So when you go ahead and do that, we will see that we have 230 grams of ethanol and 480 grams of oxygen gas. Fourth part is asking us to find the total mass of the products, now assuming perfect yield. Now in this part you have to figure out the limiting reagent because the limiting reagent is the one that determines how much product we make. Well, if you go through this stoichiometry, you will see that we have equal amounts of stoichiometry, we have equal amounts, so theoretically we should not have any reactants in excess. So if you do that, I'll go ahead and show this one. So if we have, for example, 5 moles of ethanol, based on our balanced chemical reaction, we can see that 1 mole of ethanol reacts with oxygen gas to make, let's say, 2 moles of CO2. And we know that 1 mole of CO2 is 44 grams of CO2. Now the units cancel out, and we are left with grams of CO2, and we will see that we have 440 grams of CO2. Now, if you were to do this with 15 moles of O2 gas, you will see that you will get the same exact number because then you would have 15 moles of O2 gas, 3 moles of O2 reacts to make 2 moles of CO2, so that 15 and 3 cancel out. You will have the same exact math. Now, I did that for CO2. You can do the one for H2O on your own, and you will see that you will have 270 grams of H2O. Now, 230 plus 480 will give us 710 grams of reactants. 440 plus 270 will also give us 710 grams of products. Now, this is something to pay attention to because the last question is asking us, what law do these results follow? Well, if you pay attention, you will see that we have the same mass for our reactants and the same mass for our products. And this is exactly what the law of mass conservation says. Theoretically, the mass of products and the reactants should be equal. Now, in actual practice, that may not be the case, but that's probably because, if you're reacting something and you have a gas as a product, it's just going to escape and it's hard to weigh it sometimes. I hope that all made sense. If you have any questions, stop by my office hours at CASA, and hopefully I'll see you then. Thank you.